important terms. Now what we are going to discuss? We are going to discuss definitions of the important terms used for describing the parabola. Definition of the important terms used for describing the parabola. Just look here now. I have mentioned few terms here: directrix, vertex and focus. Directrix and vertex you have already known that. What was focus? I told you. What was directrix? I told you. Now let's go for the definition. First of all, a figure is here, a parabola f a comma 0, a p, a point lying on the parabola. This is a line, it is already mentioned y, so it is a y-axis. Why this is a y-axis? I am going to tell you. This is x-axis, this is a line L, we are denoting by directrix. This is the directrix, okay. So we are having, as we have gone for the definition, Fp is equal to Pb, okay. So now let's move for the terms now. The fixed line is called the directrix of the parabola. This is the fixed line. We are not going to draw this line first, okay. This is a figure, we can't draw this line first, okay. First of all, we are having a focus and a directrix, and the fixed line is called the directrix of the parabola. This is the fixed line. Why it is the fixed line? I showed you animation. Why it is the fixed line? I described it. Once again I am going to tell you. Before this directrix, now we are having vertex. Vertex of each parabola is at the origin 0, 0. The point of intersection of the axis of symmetry and the parabola. Now listen one thing, I have not written here the point of intersection of x-axis and y-axis. No, I have not written here. What I have mentioned here, the point of intersection of the axis of symmetry. So it means this is a very important term, axis of symmetry. For this one, when focus is here, this is the axis of symmetry. From this point, any point on the parabola, when this distance, we are making this distance. Here is a distance, we are lying here. Similarly, when we are joining all these points, that makes a straight line, that is a directrix. Okay. So now point O, mentioning the O, 0, 0, sorry, that is origin. Okay, that is called the vertex. So vertex is point O in this figure. Then focus. The fixed point F is called the focus of each type of parabola which lies on one of the coordinate axes. So this is a coordinate axis, axis of symmetry. This is a point F. Now for F, we have taken F as a focus, and I have mentioned their coordinates, that is a comma 0. A comma 0. Now you can just check it. This is y-axis, this is x-axis. It means from this point O to point F, what is the abscissa? It is a, small a. Okay. So and now one more thing, that from here, from this point to this point, by the definition, it means O and M are also equal. So we are having FO is equal to OM. That's why equation of the directrix is x is equal to minus a. Okay. Now we are having chord, focal chord and latus rectum. So first let's go again with the parabola. Now just look here how nicely I have drawn a figure here. Now about this point S or F, okay, we have already discussed that this point S is a focus of a parabola. Okay. So once again I am just repeating, normally we are not using F as a focus, but in many books it is used. So basically we are going S as a focus. Okay. So I have mentioned here S with 0 comma a. Now that parabola which earlier I showed you, okay, that was in this shape. Now in this shape. So that there should not be any type of a confusion. Okay. This is the vertex now. This is the directrix. Is it clear? So we are having first of all chord. Now basically what chord is? Just look here. I have mentioned one chord written here. It means this is a chord, and it is going from this side of a parabola, point of a parabola, to this point. This is also a chord. Now this chord, what is the difference between this chord and this chord? Here it is written focal chord, not chord, it is focal chord, okay, and it is passing through the focus. This is chord not passing through the focus. This is normal, tangent, this we are knowing vertex, okay. Now it will be x-axis, this is y-axis, this is directrix. So what is the chord now? We are having a straight line joining any 2 points on the parabola is called a chord of the parabola. So we can have number of infinite chords in the parabola, okay. A straight line joining any 2 points on the parabola from here to here, that is a chord, okay. Then we are having focal chord, or as I told you, it passes through the focus. Any chord of a parabola which passes through the focus is called a focal chord. Then we are having most important term, that is a latus rectum. You could just check it. Latus rectum is a straight line. This is just perpendicular on the axis of symmetry and it passes through the focus, okay. So a chord passing through the focus and perpendicular to the axis of the parabola is called the latus rectum. Now I am going to give you a relation for the length of the parabola, okay, length of the latus rectum, not parabola, length of the latus rectum from here to here. What the length will be, we are going to drive a relation, that is called length of the latus rectum. So these were the few terms which we are going to use it. 2 terms are left, one is tangent, and this is we are going to give a very nice explanation with different examples for the condition of tangency for different conic sections, okay. So tangent, and this point is point of tangency, and from here when we are drawing a perpendicular, that is called normal. So these are all the terms we have discussed. Now we are going for the other thing.